So, we're graphing cosecant, okay? So, how do we graph cosecant? Well, first of all, we're going to need to find our angles that are transformed, right? So I'm going to write that, find the angles. That's going to be the first thing we do. After that, when you're graphing cosecant, you actually start by graphing what instead? Good. You graph a sine wave, right? And after that, you go ahead and you put on your vertical asymptotes and then your curves after that. So that's the process we're going to go through. Now, every problem I'm doing with you guys, I'm trying to throw in a little bit more. Okay, so what this problem is getting thrown in is something we didn't talk about yesterday, which is I'm putting amplitudes and midlines on there. Now, I think I gave them to you in your homework to see how you could try it anyway, but just in case you have questions, we'll go through it. But there's really nothing new there, but doing everything all at once is new. So let's go ahead and do this. Now, when you're graphing cosecant, you're graphing sine. And since we're graphing sine, the starting angles that we use are the same. You still are going to use 0, 90, 180, 270, and 360. And we're going to transform those with that set of horizontal transformation. Okay, so I'm going to subtract the 90 and divide by 3. So now 0 has been transformed into negative 30. Repeat that process for the 90. And we get 0. So now what's our pattern then? We're going up by 30 every time, right? So that means my next one's going to be 30 and 90. There you go. So these ones, we're not going to calculate these in the same way. We're just going to use the pattern to get them. So we've found our angles. And now we're ready to graph a sine wave, right? Well, I guess I'll... Okay, so I'm going to set up my graph. My angles were negative 30, 0, and so on, right? Now, to graph my sine wave, we have to look at the sine wave is going to be the same thing, right? We start by graphing our midline. So my midline is at negative 4. My amplitude is 2. So I go up 2 and down 2. Sine starts where? At the midline. So starting from negative 30, right? That's our new starting point. We're going to be at the midline when we are at negative 30. And then from there we go up. And then you go ahead and continue the curve to the left and right a little bit. Asymptote, vertical asymptotes. Okay, so we've taken care of the graph of sine now. And now we're going to put on those vertical asymptotes. Those are where the curve hits the midline, right? So I'm going to put an asymptote here, 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 and here. Okay. And then after that, we put our curves on, and we're good to go. So once again, we're just reviewing how to graph cosecant there. The real new part from yesterday was just finding those new angles, right? Not a whole lot different there.
So is that the whole gist of these last two lessons? Just the new
The angles, yeah. And we're actually going to do the same thing on Thursday, but we're going to do that with radians, and you'll appreciate that being a whole other lesson because it's really, it's the same thing, but it looks ugly because they're fractions, right? Yeah, fractions are fun. Well, so your final answer has to be in fractions, but if you have a calculator that can work with fractions, be blessed. That would be helpful. Save you a lot of time. All right, can I erase? Sí o no? Sí. All right, go ahead and do student practice 3 real quick. I gave you guys cosecants. Should have given you secant, but it's cosecant. Go. All right, so I'm going to ask Leilani, what was your first angle here? Negative 90. I'm pretty sure that's correct. Let's look at that and see. So. Oh, there's more? Thank you. How many negatives do I have? Okay, so I'll just do that. Thank you for the insight there. So cosecant, we're actually going to start by graphing sine again. And with sine, the first angle is 0, and we're going to set our horizontal transformation expression there in the argument equal to 0 and solve. So if you minus the 180 and divide by 2, you will get what Leilani said there. Oh, no, 180, sorry, I'm jumping ahead. But yeah, you will get negative 90. Okay, let's do the next one here. How's about it's Ezekiel? What'd you get for the second angle, Ezekiel? Okay, I think he's probably right as well, but let's work it out just to be sure. So after 0 with sine comes 90, right? All right, so if I minus the 180 here, I'm going to get negative 90. And then we divide, and we've got our negative 45, just like Ezekiel said. Okay, after that, we can use our pattern. Justin, what's the pattern? I know that you there you go, good. All right, so if it's going up by 45, Tanya, I'm going to have you tell me the rest. What's this one going to, what's my next angle going to be? And then? Good. All right, cool enough. Next, Jennifer's not here. Armando, what do I do now to graph this function?
First, you do your amplitude. I mean your midline.
There you go. Midline, and what is it?
It's 2.
Okay. Iman, what do I do now after the midline? Okay, so we're going to use the amplitude, which is a half. We're going to go up a half and down a half. Brooklyn, what is my starting coordinate? Close. There you go. Negative 90 at the midline. Good job. And then from there, since it's a sine function that we're graphing right now, there's no negative outside or inside. So it's just going to go up like it usually does. After that, then it wiggles around.
You missed one.
I missed one?
The 0 is up.
Ah, I'll cross that off.
gotta go back and forth. So if you start in your mind,
All right, so there's our, yes.
Instead of doing, like, I thought you go kind of,
Yeah, up a half over 1, like that. You good? All right. Melanie, what do I do now? Almost, but before, I'll give you credit for that, but before I put my curves, I'm going to ask Juliana, what do I need to do before I put my curves? The asymptotes, good. So we need one here, here, and here, and then we can put the curves on like Melanie was telling us, right here. So there's your secant function. Shall I erase? A little bit more? A bit different. One more example is when you have a negative in front of your angle on the inside, well, first of all, we already understand that's going to do a horizontal reflection, but it's kind of interesting the way it plays out when you try to graph these things. So go ahead and write down example 4. As you guys can see now, if you want to actually just start following those steps on the page, you can. So, I mean, the first one, obviously we're graphing a tangent function there, right? So you would go down to the graphing tan and cotangent. And it says the first thing you got to do is find your theta values, right? So you set the argument equal to all the tangent angles. Now we're doing degrees, right? So what are the degrees for tangents? And I hope you guys can all see that on the handout I gave you. These are the angles that you would use for tangent, right? But we're going to transform them. Okay, so I'm going to go ahead and do that now. Okay, so what I'm going to do is I'm going to do 2 things here. I'm going to multiply by 4 to get rid of the 4, but I'm going to multiply by -4 to get rid of the negative. So -4 on both sides. And what that's going to end up giving me is, okay, a positive 280. Okay, cool enough. Let's go ahead and do the next one. -45, so same thing. Add 20 to both sides. Multiply both sides by a -4. I'll just put brackets around the whole thing, put -4 out there. Theta equals 100. So now we have a pattern, but notice what's interesting about the pattern here that we haven't seen before. It's going down, and that's because there's a negative in front of that theta. The angles are decreasing. So from here to here, it went down by 180. Okay, so now if I take 180 away from 100, I get -80. And we'll just continue that process, subtracting 180. Let me know if I'm wrong. Is that right? Is that right? Okay, so there you go. Would you say this qualifies as a horizontal stretch or compression? It's a stretch, right? That got really stretched out there. That's a big stretch. All right. But it's also a reflection, and as you guys can see, whenever you have a horizontal reflection, your angles start to go backwards the other way. Okay? So that's that. We just finished step 1 on this little handout where we find our angles. Yeah.
So you determined between step or like scalar and numbers this the theta even bigger?
Yeah, like is usually tangent only goes from -90 to +90, right? That's its usual period. But now it's going from 280 all the way over here to -440. That's almost 700 spaces apart. So that really got stretched a lot. Yeah. All right, let's go ahead and continue. So we're ready to set up our graph now. So let's put those angles on there. And I have 3 negative angles, right? And then I've got a couple positive ones. Let's go ahead and put like 100 here. So if 200 would be here, 280 would probably be like over here. And then the next one would be, this space should be approximately the same distance to the next one, which would be -80, right? And then next one. Thanks. And I didn't have to make it so stretched. That's just how it worked out for me. But there's our angles. Okay, so now the next thing we do according to our little step sheet that I gave you is we sketch our vertical asymptotes, right? Because this is a tangent curve. So I'm going to put a asymptote at my first and an asymptote at the last, right? Okay. Now when you're graphing tangent, is there a negative outside the tangent? No. Is there a negative on the angle inside? Yes. So look at your sheet that I gave you here. Which kind of function is this? An increasing or decreasing one? It's a decreasing one. All right, so keep that in mind. All right, so now we're going to plot our midpoint. The midpoint is going to be at the middle angle, and it's going to be up 1. We'll call that 1 there. My amplitude is 4, so I'm going to go up 4 and down 4 from 1 there, right? Now, since it's decreasing, if I go over to my next angle, which way am I going to go? Down 4, and then over and up. And it's concave up here, it's concave down here, and I'm going to just fudge the rest of it there. And technically, we should put some more on here, but I'm kind of out of board space, but I'll just be messy. Hey. Usually. But since there's a negative on the inside, it reverses. It's a horizontal reflection. And once again, how you're going to remember, well, how you can remember that is you can either do it the way I taught you on that first day, or you can just look on the sheet here. I've got them listed out, what happens when there's negatives inside and outside. Yeah, what's up, bro?
So since the amplitude is 4, it'd be like 4 up and then over.
Yeah.
And then, so how did you get it on? Wouldn't it be on the other?
0 was, okay, that's a good question. Can I have your guys' attention real quick? So, Pro was saying, don't we go over 1 and down 4, right? So she said, but why'd you go to 100? Why don't we go to the 0? Now, that's a tempting thing to do, but look at your angles. Where any of our angles is 0. The reason why that's tempting to do is because there's a line there, right? But 0 is not actually one of our points that we use on this graph. So I appreciate your bringing that up. All right. And I know that, and I still do it sometimes. So you just got to try to be aware. All right. Now I'm throwing one at you. This is a sine wave, right? But why am I giving this one to you? Because there's a negative on the angle on the inside. That's why I'm giving it to you. So I'll let you guys go ahead and do that. So Alondra, what are the angles that we usually use when graphing sine? Good. Now I'm only going to put the first 2 there, but you're right. Jalissa, I'm going to set these equal to what? Yep. Solve both. This one's going to give you 0. This one's going to give you negative 180. So when we're graphing this, we're going to start at 0, but then we're going to go to negative 180. And that's a negative 180 degree drop. So if we do that again, we're going to end up negative 360, followed by negative 540, followed by negative 720. Okay, now my midline is at 1. My amplitude is 2, so I'm going to go up 2 and down 2. And I'm going to start way over here on the right. Now the question though is I know I start at the midline, but do I go up or down? And what's confusing here is that there's 2 transformations. There's a horizontal and a vertical. So let's see if you guys guessed right. Were we supposed to go up or down there? So I have a sine wave up here. This is what sine usually looks like, correct? It starts at the middle and goes up. Now, if I were to do a horizontal flip, now what's it doing? It starts at the midline and goes down, right? Now, what if I were to also do a vertical flip? It goes back to the original. In a way. Now, I don't want you guys to get too cozy with that thing. Okay, 2 negatives always cancel each other out. That doesn't happen with cosine. So you actually need to just visualize what happens as you flip these things around.
Wait, can you show me what happens with cosine?
Well, I can. I didn't get a graph up, but let me finish this one first, and then I will show you, yeah. All right. So here we go. We have, it's going to start at the midline, and we've established that it's going to go up. And there's our graph. Okay? So that's tricky. Now, I won't put a question like that on your test because it's not on your little handout there. But nothing wrong with learning a little bit of a challenge. I might put it on your homework, make you think a little bit. Now, Armando, you were asking about cotangent. Now, cotangent usually looks like this. So what would it look? So your question now is, what would this look like? Vertical and horizontal. Well, first of all, if I did a horizontal flip, what would this graph look like? It would still be the same, wouldn't it?
Yeah.
It's symmetrical. If just imagine taking that and flipping it over, it's going to look exactly the same. So horizontals do not change cosine. Now let's do a vertical flip where we flip it upside down. That would look like this, wouldn't it? Okay, so there you have it. All right. That being said, I don't know what time it is. If we have time, we'll move on to the next part. If we don't, we have time.
No, we don't.
No, we don't.